Let P be a point on the parabola y squared equals 4ax, where a is positive. The normal to the parabola at P meets the x-axis at a point Q. The area of the triangle PFQ, where F is the focus of the parabola, is 120. If the slope m of the normal and a are both positive integers, then the pair AM is 2, 3, 1, 3, 2, 4, or 3, 4. So the only issue I have here in terms of trying to figure this out is I've just simply never studied it. I don't know what the focus of a parabola is. I think I know what the definition is, but I don't know a formula to figure out what the focus is. Okay, well, this parabola looks something like this. Take a point P. We have a normal line. It meets the x-axis at Q. And F is the focus of the parabola. I think the definition of the focus is that, well, one definition, I think there are many. If you draw a straight line like this and then reflect it off the parabola, it's where it meets the x-axis. And of course I could derive the formula for this point, but goodness. Okay, I'm gonna see if I can derive this. This is gonna take a while. I'll speed up this part of the video. Okay, I think I've derived this for a parabola in like this standard form. I believe the focus is at 1 over 4a. So this says to find the focus, you take the coefficient in front, multiply by 4, and take the reciprocal. But we are given the parabola y squared is equal to 4ax. So I have x is equal to 1 over 4a x squared. Y squared, sorry. And so the focus, according to this, it says take the coefficient in front, multiply by 4, and take the reciprocal. So I'm going to take this coefficient in front, multiply by 4 and take the reciprocal. That leaves me with a. That'll be the x-coordinate, and the y-coordinate is 0. Okay. So now I can draw my diagram again. I'm just going to draw the positive part of the parabola. That's all we need. Okay, so I've got my point P. The normal line to P intersects at Q. The focus is F. So this is at the point A. Okay, so really what I need to do is I also need to find out the coordinates of Q in terms of the coordinates of P. So let's let this be I don't want to make it I don't want to make it look like P is vertically above F. Okay, so I guess according to the way I've done this, you know, if the x coordinate of this point P is x, then Q is always 2a, a distance of 2a to the right of that. Something didn't know about parabolas. Anyway. I'm using the wrong side of the parabola here because we were told that the slope of this normal line is a positive integer, but of course that just means it's down here somewhere. Not really a big deal. So if m is an integer, then clearly root x over root a, you know, any x is going to have to be a multiple of a, but it has to be a perfect square multiple of a. Okay, so the last piece of information we need to work out here is that the area of this triangle is 120. So I have this is the height of my triangle, and the width of my triangle Well, the focus is at, I don't remember where the focus is. Focus is at the point A. So x plus delta minus, well, yeah, x plus delta minus A, and an absolute value, I suppose, right? xp is x. Okay, so y of x times x plus a has to equal 240. Y of x is I know that x has to be a perfect square multiple of a. So x has to equal k squared a. Oops. Okay, what's the factorization of 120? Right, so this doesn't work, does it? I guess I could have just used the multiple choice answers here to like see which of them corresponds to the information given. I mean, this problem is really just a whole bunch of tedious stuff with nothing terribly interesting going on. I don't know. I'm not gonna. This problem is not interesting to me at all. I don't want to go back and figure out where my mistake is. I'm going to leave it here. I mean, it's all straight lines, distances, and factors of 120. Like, did I... Yeah, I'm going to leave it here. I don't want to work on this one anymore. feel free to leave a comment with how you approach this, or the easy way to do it, or what the answer is. Thanks for watching.